From this session, we are going to discuss 2022 past paper regarding security subject, principles of information security. So you have learned about very briefly, but effectively you have learned many concepts regarding security subject. So we'll move to past paper discussion now. And I will explain some of the things that also within this past paper regarding our uh, presentations as well. First question, state whether each of the following statement is true or false and then briefly justify your answer. A transposition cipher replaces one character with another. So transposition and substitution ciphers, we have learned these things. So within this presentation, you can get that. So see, in confusion, you are in confusion ciphers, A is replaced in in the substitution ciphers, A is replaces by B, right? That is substitution, right? So for example, like this. A letter of the plain text are replaced by another number. If there is A, it is replaced by B, for example. That is substitution. In transposition ciphers, if there is plain text is ABCD, so we are changing the location, the position of these things, BCAD, rearranging. So we can use both of these techniques into one ciphers, that is correct, but substitution only means A is replaced by B, replacing. And transposition means the change in the location or the position of those letters. So this is, it says a transposition cipher replaces one character with another, false. Substitution ciphers replace one character with another, not the transposition. Transposition ciphers doing the changing of the locations. You have to write the answer false, write it first. You have to mention clearly whether that is true or false. You will get 1 mark for this as well. There are 2 marks now. 1 marks you will get whether to say true or false, right? So when you are writing your exam, so don't forget to keep another line for whether false or true only. At least guessing right whether true or false, because it also get 1 mark. After that, don't forget to describe it. So no need to heavily describe. Just with a one sentence you have to describe, briefly describe. So you can write a substitution cipher replace one character with another, not the transposition cipher. That's all. Right. The second question. Suppose we have nodes A, B, C, D, E, and F in a network. We have to generate a total 10 keys to let every node communicate with every other node in a bidirectional secure way using AES encryption algorithm. Right. So AES algorithms are symmetric algorithms. Those are symmetric algorithm. AES under symmetric algorithm, and number of keys of the symmetric algorithm can be generated n into n minus 1 divided by 2. If it is asymmetric, that is 2 to the power 2n, not 2 to the power 2 into n. If it was at asymmetric, right? But AES symmetric algorithm, so the number of keys used there is n into n minus 1 divided by 2. Right? So you have to use this formula, right? You have to use this formula, and we'll try to, so you have to say first, you have to calculate this, n into that formula, n into n minus 1 divided by 2. So as there are how many nodes? A, B, C, D, E, F. How many nodes? 6 nodes. 1, 2, 3, 4, 5, 6. 6 nodes. So n means 6. So n means 6. N minus 1 means 5. Divide by 2. 6 into 5 divided by 2. It means 15. 15. But the question says generate total 10 keys. No, it is not 10, it is 15. You have to show the calculation, and don't forget to write false, because it says 10 Answer is 50. We'll move to next question. The data encryption standard DES algorithm encrypts 30 bytes of a plain text message to 32 bytes of a ciphertext when it uses electronic code book ECB mode and the public key cryptography standard 5 PKS 5 padding scheme. What is mean by padding scheme? Padding scheme means if we have in remaining parts, we have to padded those things. Padding means adding more bits. If the block size is not fulfilled, we are adding more bits. Just like adding leading bits like that. So padding like that. If we having less number of bits, more less than expected block size. So we have to use some extra bits. That is called padding scheme. So DES algorithm. What is the block size? Did you remember that? What is the block size of the DES algorithm? So if we find it, DES algorithm. So these block ciphers, and you can see in your presentations there are plain text encrypt 64-bit data blocks. What is the block size of DES? 64-bit, but it is bit. I have mentioned it in the bit. So how many bytes? You have to divide by 8. So you know that 8 bits are 1 byte, no? So if you divide this by 8, it means 8 byte, right? 64 divided by 8 means 8, no? So it is 8 byte. So the block size of DES algorithm is 8 bytes. You can write it in bytes. 64-bit mean 8 bytes. The block size of DES algorithm is 8 bytes, right? So the plain text is 30 bits. 30, not bits, 30 bytes, sorry, 30 bytes. So we have to encrypt it as 8 blocks. So first block, the second block, the next block. So how many bytes now? 24 bytes. How much remaining? 24 means this is 30 bytes now. Now 24 here, right? 24 bytes here. And again we need extra 6 bytes. But the block size is 8. So you have to add two extra paddings. Because it says use PKCS5 padding scheme. It means don't use only 6 bytes there. Here also you have to use 8 bytes. Because padding scheme means you have to add extra bits to pad it. So there is only, so 30 means 8, 8, 8 and 6. That is 30. But extra 2 you have to add as there is padding scheme. So then your ciphertext become 32 bits, 32 bytes, 32 bytes. Ciphertext is altogether with the padding bytes as well, 32 bytes ciphertext you will get by the DES algorithm. So you have to explain like this. You can draw this kind of diagram as well. Then it will be much clearer. Or else you can say the block size of DES algorithm is 8 bytes. The last, here it says in very briefly and very clearly, the last block will be padded with 2 bytes. Thus, ciphertext is 32 bytes. We'll move to the next question. Suppose we want to use Diffie-Hellman Tree Agreement Protocol 2 parties, A and B. So nothing to worry about. You have learned about Diffie-Hellman and they are given all those necessary details. You have to show whether this is correct or wrong. Just substitute to the your formula. So let me show Diffie-Hellman this one. right? You have to show what is the key size is, the key. So you can use this one or you can use this one. Both are same. So here the same key generated in two formulas. You can use this formula or else you can use this formula. Only one side is enough. Both are same. So we'll say you are going to find this first. So first if you find X value, then you can find this key size. Because here it needs X value. Because of that, you have to find X and apply to here. The same thing, or else you can find Y here, right? You can find Y here and apply to here and find the key size once again. With that, using that Y value. Just like a cross, you can, if you are finding X value, you can find key size from here. If you find Y value, you can find key size from here, this formula. Only one is needed. Shall we find X value first? Here. So I'm applying and going to find the X value. So according to your paper, let me show. So to find X, you need, what are the values you need? G, here you want to find the G value, simple X value and simple N value. So all these details are given. G is 5, right? Simple X is 7, simple X. And N is 11. Then apply and just you can find the X value. So I'm substitute to this formula. X equal G is 5, right? G is 5 as given in the question. Simple X is 7. Simple N is 11. So answer is 5 to the power 7 is this much 78,125 mod 11. So you are allowed to use calculators. Non-programmable calculators are allowed to use, right? So once you get the answer, 78,125 divide by 11 and the remainder. Mod 11 means you have to divide this number from 11 and get the remainder. You can use a simple calculator and divide from 11 and get the remainder of that. So once you divide from 11, you can get the answer. You have to find divide from 11 and get the remainder. So remainder is 3. Remainder, you have to get the remainder of that. So 78,125. You can use calculators for this subject. 78,125. You have to find first of all, you have to find 5 to the power 7, right? So after that, you can get this one. And you can divide from 11. Once you divide from 11, you will get this much now. 7,102 no. So you have to get the mod value, not this value. So 7,102. So shall we get 7,102? So the remainder is the mod value you have to use. So you can roughly say once again 78,125 means once you divide by 11, you will get this much, no? So 11 into 700, 1002 if we check. 11 into 7,102 if you check, it gets this much. 78,122, no? So, you have 78,125. This is how you have to get the answer. 78,125. It means how much remaining will be there? 3. Because you have 78,128, no? 125, no? The answer is 78,122. So remaining is 3. 3. So that's how you find x value, capital X value here. So if you find x, then our target is finding this key value. So if you find x value, you can use this, because using capital X value, you can find key now. K equal, it means key equal x, x means 3, y, simple y. Simple y according to your question is, simple y is 5. Here simple y is 5. Simple y is 5. So 3 to the power 5, 3 to the power 5, mod 11, mod 11, mod 11. So 3 to the power 5 means 243 mod 11. It means 1. It means 243 divide by 11 and get remainder. So once you divide from 11, you will get 2. Here 24 divide by 11 means 2. It means 22, no? So, uh, 243 divide by 11 and get the remainder. You can use calculator as I shown previously. So here 2, it means 22. Once it is 2 remaining, and 23 again 2, no? That is 22, remaining 1. Remaining 1. The remaining 1 comes here. Answer is 1. Answer is 1. So that is 1. So you have to show the calculation like that. And it says session key between A and B is 1. Correct. We also get 1. So you have to write true and show the calculation. Show the calculation. So only one side is enough. It means you don't need to show both of these session keys. The same key generates. You can use either this formula or else this formula. I use only this. That's enough. Find x value and find this key, this session key. That's enough. No need to find in both ways. Right. E. Nimai generates two prime numbers P7, Q17. RSA key generation process. He selects public key E is 5 together n equal 119. His private key also says 77. So we have to say whether this selection is correct or not. So show to whether this selection correct or not, use this formula. We didn't discuss in the workshops this one. So please get this one from this past paper. If you get this kind of question, right? If you get this kind of question, you have to confirm that is using this formula. This is a standard formula, right? You can use directly and show whether this is equal to 1. That's all. Then it means if this is not equal to 1, this selection is not good. This selection is not good for the key. But if this is equal to 1, it means the selection is correct. Right? Use this formula. You have to write this as, this is E into D mod P minus 1 Q minus 1. So E is, you are given all the things. Just substitute 5. D is 77. Mod 6 into 16. 6 means P minus 1. So P is 7, no? Minus 1 means 6. Q minus 1. Here 17, no, 16. So once you simplify it to 385 mod 96, it means 385 divide by 96 and get the remainder. You can use calculators, right? So here 385, no? So use the same method as I showed. 385 divide by 96. So you can just use this. That is 4, around 4 now. Now I'm again 4 into 96. I am finding 4 into 96. 4 into 96. Then it says 385, 84, but we have 385. The difference is 1. You have to get like that. If you use calculator, that is the method. The same method showing that, right? Get the mod, the remainder. You can use that method. It means 1. It means this selection is correct. This selection is correct, true. If it is get 1, with this formula, if you get 1, that means the selection is correct. If you get if you get any other number without 1, it means that selection is incorrect. F. Nimal has an RSA public key. RSA. We have learned about that in the workshop. RSA and RSA public key, private key. RSA encrypts. Don't forget, I have also highlighted in the workshop. RSK algorithm uses to two things. What are the two usage of RSA? Can you remember? What are the two usage of RSA? Encryption as well as signing. Encryption as well as signing. Right? For encryption, we are using RSA. For signing also, we are using RSA. For encryption algorithm, I have given to you. And also for signing, I have learned to you. I have said the mechanism. What is the signing mechanism also I have teach to you. So this is RSA encrypts. Just you have to add the formula as it is. RSA encrypts, right? So we'll show. So here the plain text m equal to plain text. M means the plain text here. It says 2 and it says hypertext 29. So whether we have to say whether this is true or false. Then go to the RSA. Then go to the RSA algorithm. Right. So here, as I said, RSA usage, there are two usage, encryption and also signing. So we are interested in encryption here. So this is the formula, right? Just you have to substitute. C equals the hypertext we are going to find. P means the plain text. So here it gives us M equal to. So plain text is 2. Here it says M. They are using different symbol. That's okay. So here says M equal to means the plain text. Right? E. What is the value of E? The value of E is we'll look. The value of E is 7. It says see EN 733. Value of E is 7. Value of E is 7. 7 mod N. N is 33. Just you have to simplify this. 2 to the power 7 is 128. 128, the same thing you have to learn about this calculation, right? You have calculator, but you have to learn about how to get the answer from the calculator. Do it by yourself. 128 divide by 33 and get the remainder. If you can divide the 128 by 33 and get the remainder. So answer is that 128 divide from 33. So how to get the answer? Once again, I'm doing the same thing. 128, sorry, 128 divide from 33. With the normal calculator, you can get the answer, right? 3, no? 3, right? 3. Don't get this point number, only get the integer, 3. The same thing I'm again showing. And get 33 into 3. What is the answer? 33 into 3. What is the answer? 99. Now get the difference with 128 minus 99 means 29. That is the answer. Right? I'm showing. So the simple definition of the simple definition is 128 divide from 33 and get the remainder. So I'm showing how to use normal calculator to get this, right? If there is no mod operators, how to get that. So that is 29. Answer is 29. It means hypertext is 29. So here you have to show that calculation using that formula and it gets 29. It means true. Don't forget to write true because it also get 1 mark for that. True. The next about also RSA, but it is about also RSA, but it is about signing. It is about signing. It is about signing. So in signing, what happens? So I have teach you about the signing in RSK. If you get not about the RSA, but I have teach you about what is mean by signing. In signing, what happens? In encryption, we are using encryption in this we use encryption in this. So in encryption, we are using, right? So this is encryption. This is what I want to say. This is encryption. In encryption, we are doing with recipient's public key. We are doing with recipient's public key. Encryption doing using recipient's public key. And the decryption for decryption we use recipient's private key. For encryption, we use recipient's public key. For decryption, we use recipient's private key. Recipients. But in signing, what happens? In signing, sender's private key doing sign or the encrypt of signing is happens. Encrypt or signing is happens sender's private key. And decrypt or reading the signature doing sender's public key. Sender's side. Sender's private key. Encryption happen in signing. Decryption in signing happens. Sender's public key. Can you get the difference of that? So the next one is about signing, but about RSA. So as RSA, we have to use this formula. What is the RSA? The standard formula? RSA standard formula is this one now. So then sign in means encrypting, signing, right? So you have to use this formula. But the difference is instead of the receiver's public key, we are using private key. We are using private key because it is signing, no? Signing. As I said, sender's private key need. So you have to, instead of this E, simply use D. Private key. Use the private key. If it seems like complex, just remember this formula as it is. If it is signing, PD mod N. D means the private key. I show how it comes, right? How it comes, I shows that bit. Right, so PD mod N. Then simply P means plain text history. C equal plain text history. D means private key. Private key. So It given in here. The private key is 3. D. D. Here it says private key is 3. So 3. 3 mod n. N means, here it means 33. According to the question, it shows 33. So 3 to the power 3 means 27 mod n. There is a mistake in this paper here. This is not true. This is false because 3 to the power 3 means 27. No. So they are taking it as mistakenly as 9. Right? It should be 27. 27 mod 33. If you divide 27 by 33 and get the remainder, so you can see 27 is less than 33, no? So you can't divide it. So remaining is 27 itself. Because you can divide 27 by 33. Can you divide it? Can't. So it is 27 itself. 27. So answer must be false, not true. False and show the calculation. So they have mistake. All the other things are correct. Applying and substituting is also correct. But here, 3 to the power 3 is getting them as 9 incorrectly. That's why this should be 27. So then answer is false because they are saying Kamal received signature 9, not 9, but it must be 27. The next question. The SHA-1 algorithm generates 128-bit hash from input message of 64 bits. Whether we don't care about what is the length of the input message. Hash function every time generate a fixed length. It doesn't depend on the input message. We have learned that, right? Without depending on the input message, every time it generates a fixed size. But the problem is SHA-1 hash algorithm hash value is 160, not 128. So you can say it does not depend on the length of the input message, even though you given this message or not. The SHA-1 algorithm also generate 160-bit hash value. You can use this. And this is false because it says 128 now, right? Whether we'll say you are given the input message is 128 bits. What is the SHA-1 algorithm hash value? Also 160. It does not depend on the input message. However, they are saying 128. No, that is incorrect because SHA-1 bit hash value is 160. I have given in the workshop slides also what is the SHA-1 algorithm bit size, right? The hash value. Right. The question we didn't cover this one in our workshop, but I will just explain. CRT encrypt plain text faster than CBC. It is true because CRT encrypts plain text parallelly. Thus, because of that, it is doing the parallel mechanism. Because of that, it is faster than CBC. That is true. J. The greatest common divisor 18 and 300 is equal to 6. So we didn't cover this also in the workshop, but I will teach you within this. You can get the method. This is very simple. If you ask to find the GCD and given these two values, what you have to do is very simple method. You can understand with this. 300. So get larger value. That is 300 no equal and get the smaller value. 18 no 18 into, find the value. 18 into, you can get 18 into 60 plus 12. The remainder is 12. Did you get the method? It means get the larger value here and the smaller value here and check how much units of that is equal to 300. So just you have to check 18 into 5, 18 into 10 likewise. You know that 18 into 10 is also 180. That must be more than that. Then get get a smaller nearer value. So that is 18 into 16 we can get. So if you get 18 into 16, that is much near and it is smaller than 300. If you get 18 into 16, that is nearer to the 300. Get that value and get the remainder. Get the remainder. So 288 means remainder is 12. Like this you have to write. And after that, then I will use this same one. So then again rewrite this number and this number. Now we have to find GCD of 18 and 12. The same thing again and again you have to repeat, just only that. Then get the larger value from this. What is the larger value? 80. Do the same thing. 18 into 12, how much? 12 into 1 and remainder is 6. Then again get 12 and 6 GCD. Get the larger value. 12. 12 into 6 2. 6 2. How much? 6 to 2 plus 0. And until if you get GCD 6 and 0. So GCD is 6. GCD is 6. You have to do this process, repeat this process until it comes 0. So the remaining number is the GCD, that is equal to 6. So I hope we have discussed the first question entirely. I hope all the things are very clear and we did this with this very small workshop. And in the second part, I will describe rest of the paper of this 2022. The second question and onwards, I'm going to discuss in the next part. If you have any more questions, even if you ask this recording, please again and again listen and try to understand. This is not much hard. You can do this with very small content. You can cover so much. I think you can get some confidence with this. In the second part, we will move to the second question.